Down. Hello, good morning, future clinicians and scientists. Welcome back to Medical Biochemistry. Today, we embark on a fascinating journey, one that begins on our plate and ends inside ourselves. We are launching our new lecture series on lipid metabolism, and this is lecture number 1. But before we understand how the body burns fat for energy or builds membrane with it, we must first answer a fundamental question. How does the body even get these water-hating molecules through a water-based digestive system? In this session, we will bridge the gap between lipid chemistry and clinical biochemistry. We will explore not just what the classes of biochemistry or the lipids, but how the enzymatic and hormonal mastery behind their digestion and absorption. By the end, you will understand why a genetic mutation in the chloride channel can clog the pancreas and why an anti-obesity drug literally blocks your gut from soaking up the cheeseburger. So open your minds and let's get greasy, scientifically speaking. This is our roadmap. Today, we are not just defining lipids. We are following their journey from the mouth to the bloodstream. Note the date. This is the beginning of our mastery of lipid metabolism. The definition is the key: hydrophobic or amphipathic. This property dictates everything: transport, digestion, and disease. The 5 classes here are the characters in our story. Waxes are the protection. Think earwax or plant leaves. Triglycerides, fats or oils are our energy reservoirs. Phospholipids and glycolipids are the architects of the cell membrane. And steroids, like cholesterol, are the messengers. So let's start with the simple lipids. Note this progression: mono, di, and triglycerides. This is not just chemistry trivia. During digestion, we break them into tri, to di, to mono, and note tags. Triacylglycerol is the king of the storage. Where? In our adipocytes. Most of the fat you eat is tagged. Plants store it in seeds. We store it in our bellies. So, what about complex lipids? These are the double agents. The very first part is the water-loving, and the second one is the fat-loving. So they are critical for emulsification. The glycerol-based ones comes from the glucose metabolism. The sphingosine-based ones, they start from the amino acid serine and palmitate. Sphingomyelin is a major component of the myelin sheath around the nerve. Damage it, and you get neurological disorders. So, what about the derived lipids? So, derived means they come from the simple or complex lipids. So, prostaglandin are local hormones. They control inflammation, fever, and the pain. So, that's why NSAIDs like ibuprofen block their synthesis. And terpenes, that's why carrots are orange, beta carotene, and leaves change color in fall. So they are the examples, or they have got the property of being the xanthophylls having in its structure or in its composition. So what about the fatty acid structure and nomenclature? Let's start with the omega-3, omega-6, and 9. The omega number tells you where the double bond or the very first double bond is from the methyl group or methyl end. Omega-3 at the carbon 3. That's flaxseed and fish oil. Anti-inflammatory. Omega-6 at the carbon number 6. Examples are the vegetable oils. Pro-inflammatory in action. Our ancestor ate a 1:1 ratio, right? Today, we are at 20:1, omega-6 to omega-3. That imbalance drives chronic disease. So let's move to cholesterol and its biological importance. Cholesterol gets a bad rap, right? But it is essential, very essential. Every single membrane or cell membrane needs it. But here is a clinical pearl. Imbalance in the lipid metabolism are at the heart of the three modern epidemics: atherosclerosis, that leads to heart attacks, diabetes, and obesity. You cannot be a good physician without understanding these pathways. So, what about its importance? So they are very important for, having lipid are, considered as a major source of energy for the body. Lipids serve additional functions in the body. For example, some fat soluble vitamins have regulatory and coenzyme functions, and the prostaglandins and steroid hormones play very important role in controlling the body's homeostasis. So deficiencies or the imbalances of the lipid metabolism can lead to some of the very major problems encountered by the physicians. As we mentioned earlier, the obesity, the diabetes, and atherosclerosis. So what about the digestion of the lipids? So digestion can be divided in stomach and in intestine. So let's start with the stomach, right? Digestion starts before food hits the small intestine. Lingual and gastric lipases are major or are minor in adults, but critical for infants digesting milk. And here's a clinical pearl. In cystic fibrosis, these enzymes become a patient's only hope because the pancreas fails. So, what about cystic fibrosis? A clinical detour, right? Cystic fibrosis is a masterclass in biochemistry. A single chloride channel defect leads to the thick, sticky mucus that blocks the pancreatic ducts. No enzyme reach the gut, and these patients pass bulky, foul-smelling, greasy stools. That is a hallmark feature of cystic fibrosis, that is steatorrhea. They need oral pancreatic enzyme supplements with every single meal. So, what about emulsification? In intestine, the digestion occur, by these processes at the level of duodenum. So there are two mechanisms involved behind this: the involvement of the bile salts, detergent action, and peristalsis, that is mechanical mixing. So emulsification is the key. Think of making a, a mixture. Oil and vinegar separates until you add mustard, an emulsifier. Bile salts are your only or your body's mustard. They break large fat globules into tiny globules or droplets, increasing surface area of 1,000-fold for enzymic action to attack. So, pancreatic lipase is the workhorse, but it hates water. Colipase or colipase is its life jacket. It holds the enzyme onto the fat droplet. Do you remember Orlistat, one of the drug, right? It inhibits this lipase activity. You eat fat, you do not absorb it. It goes right through you. Effective, but with messy side effects like anal leakage. Patients must eat a low-fat diet on this drug. So, cholesterol esters are storage forms. You must hydrolyze them to free cholesterol to absorb it. Phospholipase A2 is the enzyme that gives us arachidonic acid from membrane phospholipids, the precursor to those prostaglandins we discussed earlier. And note, both enzymes require bile salts. No bile, no fat absorption whatsoever. So now let's discuss the hormone control of lipid digestion. by a hormone that is cholecystokinin, CCK. CCK is the director of display. Lipids in the gut trigger cholecystokinin release. CCK tells the gallbladder, contract, tells the pancreas, secrete enzymes, tells the stomach, slow down, don't flood the small intestine. This is the ileal brake. It ensures thorough digestion. If you remove the gallbladder, cholecystokinin still works, but bile dribbles continuously instead of being released in a pulse style manner, right? So now let's move to the absorption, mixed micelle formation. Micelles are the delivery trucks. They are 100 times smaller than emulsified droplets. They ferry the digestive lipids right up to the brush border membrane. The lipid diffuse out into the enterocytes. Note that bile salts themselves are not absorbed here. They recycle back to the liver through the enterohepatic circulation. Also, short and medium chain fatty acids like the coconut oil are water soluble. They go directly to the liver via the portal vein. No micelle needed. That's why MCT oil is used in malabsorption patients. So, and that class is the miraculous journey of lipid from a globe of butter on your toast to a mixed micelle dancing at the edge of your intestinal cell. So let me leave you with two clinical takeaways. Any defect in the bile production, pancreatic enzyme secretion, or the lymphatic system will cause fat malabsorption and steatorrhea. And Orlistat works, but it teaches us a harsh lesson. If you don't absorb fat, you will excrete it. So next time, in lecture number 2, we will follow these lipids inside the enterocytes, resynthesize into chylomicrons, packing into lipoproteins and release into lymphatic system. This is where transport metabolism begins. If this lecture helped you clarify the fog around the lipid digestion, hit the like button, share this video with your batchmates struggling with the biochemistry, and subscribe to our channel and press the bell icon. You never miss the upcoming lecture and the Lipid Metabolism Series. I'm Dr. Muzammil. Keep questioning, keep learning, and remember, every single disease has a biochemical story. Until next time, stay curious. Thank you very much.